So I'm going to, in 20 minutes, do the impossible task of trying to go through the essential guidance if you want a good-looking concrete. And I'm going to start off by talking about precast, and I'm going to then talk about in situ. Some of them have similarities of issues that I'm going to pull together at the end. So, first thing to recognize, if you want visual concrete, you need to do a little bit more extra effort in your specification, but more importantly, within the manufacture and the making, because there is an enormous amount of concrete used, but actually still only a small amount of it is seen. Much more these days, I would say, than 10 years ago even. There's a lot of people who are looking to expose their concrete, but you can't just assume that if you're saying you want concrete, that it's going to look good. Okay, so you think about it as a specific product. It's a really important thing to recognize. So do some research up front. This is a collection of some generic guidance that's produced by ourselves, the Concrete Society, Construct, various different players within the organization. There's many more information as well, specifically produced by manufacturers and people within the industry if you start getting down to the next layer. But certainly do some research and find out what it is, get a bit of training, listen to the webinar, something like that, Next thing is really important, and this happens a lot. Which one are you going for? Even more important than if you were just deciding whether you're going to go off-site or not off-site, recognize as early as you can whether it's going to be a precast solution you're looking at or in situ. If it's precast, is it architectural precast that you're after or structural precast? Those are very different beings or products, if you like. Structural precast, most of that isn't seen. Some of it is good enough quality to be, but it's the grey stuff. It's based on grey cement. Its whole thing is about structure, often hidden. Architectural precast, its whole being is about being seen. That's why it's called architectural, because it's what we architects are interested in. It's the bits, in a way, structural engineers are more keen on that stuff than we're keen on this stuff, hence the name, very broadly speaking. So which one, where do you sit? Now, it may be aesthetics that is driving that solution between whether it's precast or cast in situ. If you are after green, lace-embossed concrete, you're probably not going to go cast in situ concrete. Okay, that's an architectural concrete finish. In fact, all of these are architectural precast concrete finishes, which are achieved using a greater variety of basic raw materials and finishing techniques and care that is possible in a factory. Actually, in terms of the way that it's made in a factory. And that's a really important part of the process, because understanding the making of concrete, whether it's precast or in situ, is fundamental to getting a really good solution. Actually, fundamental to ironing out costs that don't necessarily need to be there. In precast, for example, it's important to recognize that you're casting with the surface that you want to see underneath. So I would say that casting upside down, but it's not quite. But get into the mindset of recognizing that it's a casting process. Some manufacturers are doing a very bespoke solution. Some of them are incredibly highly automated. I just chaired a session earlier on where they're talking about how directly from the BIM model is bending with all the rebar and it's going straight into the manufacturing systems, and incredibly highly technical. Different manufacturers have different capabilities. So even if you decided you're going to go down the precast route, making sure that you're talking to the right precaster to do with the scale of project that you're after is an important process. But also, how is it made? And how is it then going to be lifted and transported about? At some point, this thing's going to need to be picked up. So wherever those lifting eyes, on that stair, those lifting eyes are on the treads. Now, that's going to be very visible afterwards, isn't it? So therefore, how is that going to be finished? I would therefore suggest that probably has a timber tread on the top, and what they're focusing on is the underside being the architectural expression. So that's a really fundamental part of thinking about it when it's made. Which is the unformed face, which is the formed face, and where are those eyes going to go? And that's going to be all ironed out, evolved by talking to the precasters really early on and understanding those processes. What finish do you want? Surface texture. This is all pretty the same mix. It just looks completely different because there's a different post-finishing technique applied to it. You see how that could be a really interesting creativity that can be applied to one panel, but how fundamental the finishing process is to the aesthetic. So consult early with suppliers. Many of them with architectural precast have got a huge range of established mixes that they've got and samples, and they can show you what to use. Do put in a full-size mock-up though, really important. So you can spec to sample, but when you get to spec to standard, you're going to be wanting to look at full scale to be making sure that you understand that the standard is the finish that you're after. and set it out. Precast is really important. Think about joints really early on. You're in denial if you think you won't see the joints. There are tips and tricks of things of how you can do to minimize that, incorporate it within the architecture, but optimize repetition as well. All the cost within concrete generally is often to do with the mold making and the care and attention. It's the concrete itself is not the tricky bit, it's the mold. So when I talk about cast in situ concrete, really good cast in situ concrete is actually usually really great joinery. Okay? It's actually the making of the mold. So it's equally important, maybe even more important with cast in situ concrete, to understand the process of the making. Because it's being made on site. This stuff is being turned up from a local batching plant. So immediately you can see who your suppliers are, because you can Google ready mix and work out where they are around your site. Make sure they're geared up for visual concrete. Most of them are, but if you're in the middle of the countryside somewhere, they might not be. So you want a wet batching plant. It's going to be delivered in a truck. It's not mixed there, it's mixed here. Poured into a formwork that you've designed as architects. We are going to be asked what that form-facing material is. One of the most important decisions that we can make as architects, because it creates not only the texture, but also the surface reflectance and even the tone of the concrete it can impact on as well. Now, in terms of the design, we don't design the support structure, a system to that. In fact, the structural engineers often don't get involved with that. That's usually that's designed by a framework contractor, a formwork contractor rather, in response to the tolerances and the performance that we're giving. In fact, even when you're designing with a mix, unless it's a very large civils project or a very intricate, most of the time the actual concrete mix is designed by the guy in the batching plant, using structural engineers giving a performance spec or a little bit more detail in terms of the parameters of what's needed, but the responsibility for what that mix is that's going to come to you is going to be made here. So that's an important mindset, I think, in terms of understanding the processes that are going on. Most of the time, cast in situ concrete is an as-struck finish. So it's literally what comes out of the tin, if you like. So that is it ply-faced is ply formwork is a very common type of formwork system, but this is why the importance of what your formwork is lined with is really important. You can get a timber a texture on there as well, but these days, as opposed to in the 60s and 70s, that will be a thin piece of timber that's used to line the formwork. So you'll still have the ply or whatever system you've got, and you're lining it with just something to give you the texture you're after. You can do some post-finishing afterwards. You could shot blast, you can do some extra treatments if you want to, but typically that doesn't happen with concrete. So in choosing the right formwork-facing material is hugely important. The structural engineer, the contractor is usually going to be making a decision based on cost, repetition, how many times he can reuse it, and we're going to cut through that as architects with aesthetics. Any sensible construction decision, we're going to cut through and go, oh no, we want a shiny soffit. Or you might say you want a matte soffit. Now that's a mistake, but that's the difference between a board that doesn't breathe, which gives us a sheen or a high reflectance, and a board that does breathe. So a high density overlay, a medium dense overlay. There's some examples in our panels over there you can have a look at after. So you see how important it is to make for that aesthetic decision. That's the sort of thing that we as architects are going to be asked the questions, what to use. This might be the most important slide, I'd say. Managing expectations. Go and visit examples, benchmark them, put those benchmarks in your specification. It's absolutely the best way of being able to explain what you mean as being good enough or the right standard. Concrete can be used, it can be rough as anything and used for a cowshed, or as beautiful as an Olympic diving board. But actually, Zaha Hadid architects may have wanted something that was rough, and they thought that was the appropriate aesthetic. Who knows? One person's beauty is not another person's, okay? So if you walked into a building, you take your client to the building, you go, oh, if it comes out like this, I'll be happy. Put that in the specification. Why not? Best way of doing it. But don't forget, when you're looking at it, you don't look at concrete like this. You have to 3 meters. It's an overall. If you don't want color or tonal variation, if you don't want holes and lumps and bumps, you don't want cast in situ concrete. Or you might do, but you want to paint it, okay? That's what you got to recognize. This life is what I love about it. It's what we love about it. It's a natural material, but how much is too much? So that's hence the challenge. That's why you benchmark. So this is concrete, for those of you forgotten or don't know and reminded. The important thing is when you're within the specification is, in order to get good-looking visual concrete, each pour each batch within the precast plant, every element has to be exactly the same each time, used in the same way, but the same proportions. And the reason for that is a bit like baking. You need the same ingredients. You start tweaking an ingredient, something else will happen. Okay? So it's very important to recognize that. There will be a bit of admixture in there to make the concrete fluid enough. But again, we don't have to worry about that too much. As designers, structural engineers might get a little bit more involved. That's there as a response to what we're saying we want, which is normally this. Maybe a bit different. Structural engineer, be interesting to see what you respond to. This is a fairly well understood recipe, if you like, for good-looking concrete. And what it's saying is a minimum amount of cementitious stuff, the cement, that's the binder, the glue that holds it all together, a minimum amount of that to get a good surface finish, the right relationships between the sands and the aggregates. You want it to flow nicely. You ideally want this mix to be pumped in, and pumped in through a tremie and then pulled up and vibrated as it goes and pumped in like that, rather than skipped in because it's going to stick to the sides of the formwork and it's not going to be great. So for that to be fluid enough, it wants to be a minimum of an S3. That's what that consistency means. It means it's a slump. But you actually want a low water cement ratio. So those two things together says to the guy in the batching plant, okay, a little few drops of magic plasticizer, it's just going to make this thing flow. Okay, you do not want somebody to be adding water on site anyway, but you really don't want to be doing that for visual concrete. You'll change the color, the tone of the concrete completely. Or you might be going self-compacting. Everyone heard of self-compacting? These guys absolutely have. And project, did you? Yes, you're going to talk a lot about self-compacting concrete. So this is concrete that flows. So I call it sometimes the Heineken of concrete. It reaches the parts that other concrete can't reach, flows in, and only people of a certain age get that joke. Anyway, so if you've got really congested reinforcement or lots of services in the mix, this will get all the way around it, and it doesn't need to be and shouldn't be vibrated. So you've taken out the area of risk associated with the pokering of the job. And you can get some specifically designed concrete mixes off the shelf, proprietary mixes that are designed for visual concrete. Now, one of the things that we will be asked as architects to input into the structural engineering spec is, well, what sort of colour or tone or what type of cements are you after? Now, the thing that gives concrete its colour is the cement. Okay, so and cement's typically grey, which means concrete's normally grey. But actually, concrete's been getting lighter over various recent years, and that's because increased use of this stuff, GGBS, ground granulated blast furnace slag, lowering the carbon footprint of concrete, but making it lighter and making the colour of the sands start to come through much more. The other alternative is fly ash, so that gives it a steelier grey colour, also lowers the carbon footprint, or actually pigmented concrete. 10 years ago when I started this job, I wasn't allowed to talk about ready-mix pigmented concrete. It existed, but not enough people were doing it. But now they are. So that's a bag of pigment going in the back of the ready-mix, mixed around. Very, very common that's, as a means of being able to tint precast, although they often use the natural sands there as well, but definitely possible. So understand which direction of travel, if you like, you're going into, and then test out those. The most sustainable thing is to be using whatever the local batching plant has got in its plant, or whatever mixer available, and using the natural aggregates and sands that ready-mix contractor has got in his ready-mix plant. You can get extra stuff brought in if you really want to, or if the job's big enough, but generally that's your local vernacular concrete, if you like. You know, it's the local stuff, so use it. But find out what colour it is or tone it is. You might be able to tweak a little bit, but certainly, again, build a mock-up. And then this time you are measuring standard, but you're measuring and effectively training quality of build, because that will be the first time those guys have built that formwork in the way that you've designed it. And we expect it to be zero tolerance and perfect. Well, you're prototyping on site. Cut them a bit of slack is usually what I say. Okay, so but that's the important part of that process. So definitely, if you can, build in that you're doing some samples. Simplify the tender information, hugely important. You want to be able to squint at a drawing and know where the visual concrete is. You need to be elevating where those ply boards are, because you will still see the lines. Think about achievable details. And this is the same for precast as well. You know, concrete works best when it's this big, bulky stuff. You know, you can't really get down to really fine details. But what are the edges you're going to go after? Where are your construction joints? When the guys go home at the end of the day, or there's a cold joint, you know, that's a risk area. Maybe put in a recess of a fillet so that you're separating out the pores from one to the other. Think in 3 dimensions. put those 3D drawings in your tender so that everybody can see what that mold looks like. So remember I said that's where the costs were, and then you can work out that that's where you're going to be pouring, and that's equally important for precast as well, so that you're optimizing the use of the molds. Simplifying information using standardized specification documents. The standard for the finishes are basic, ordinary, plain, and special. Where do you sit within those? You might be aspirationally special, maybe, or it might be plain. Maybe you're in between the two. I don't think that matters too much. If you use this, it's very clear communication right the way through the process. And then last 2 slides, which actually could be lots of slides. Experience, diligence, and good workmanship, really important. It's a whole team effort, but the work that the contractors are doing on site, could ruin a great spec, or actually could help bring in a lot of information to help uplift somebody, an architect who doesn't know what they're doing. Equally, cleanliness and communication. Everybody needs to know that's a visual concrete site. You don't want the electricians suddenly going around and putting their yellow spray all over that lovely concrete, that you're expecting. Adequate protection. And then finally, coordinated remediation. It may well be that something is needed to make that concrete look a little bit better than it was. Recognize where the risk areas are. Maybe you might as well just leave it and recognize that you can come back and do a little bit to it. But what I always say is, if you're in doubt about whether any work is needed on that concrete, then don't do anything. It will get better over time. Never look at concrete when it's first been struck. I always say it's like looking at someone first thing in the morning. That's just not fair, okay? They need a bit of time, okay? It gets better. You'll see the lumps and bumps, but don't judge it. Just don't judge the tonal variation. It will get lighter as it goes on. And then finally, absolutely finally, it is a team effort. So structural engineers will write the spec, continue to write the spec. We'll be asking us as architects to input in the aesthetic part of it. That needs to be a coordinated spec. But if you can get as much input up front from the precasters, from main contractors, to input to make that an enriched and as informed specification and construction details as possible. And then finally, one of my favorite projects that hasn't been finished yet, but and we'll hear about that this time next year, I expect. Anyway, thank you very much.